Chain rule.
Yeah, chain.
As we look at this, two different ways we could talk about this. But probably to make life easier, we're looking at a log. Okay, it's natural log, but it's still a log nonetheless. There's a power of 2 there. What can I do with that power of 2 before I get started? Is move it out front. Okay, now, we could, I'm not going to say you couldn't just go ahead and do this as something raised to the power of 2. You know, you'd be doing the chain rule 3 times. As it is, we're going to be doing the chain rule twice. So, probably the best situation is to rewrite this as 2 times the natural log of x squared plus x plus 1. Okay, that is one option for starting this problem. So I haven't done a derivative yet. I've just rewritten the original problem. Okay, so when we go to do derivative, f prime of x, the 2 is just a coefficient, right? So with that 2 just being a coefficient, it's just going to essentially kind of carry down. How do we do the natural log of something?
1 over x.
Okay, normally it's 1 over x. In this case, I'm going to say 1 over,
2.
no, 1 over whatever my current inside is. Okay? Chain rule. You have to do pieces. We start off just doing the derivative of the outside. The derivative of the outside is how do we do the derivative of natural log of something? We normally say derivative of 1 over x, but it's going to be derivative of 1 over whatever was there. Okay? So I'm going to keep my 2 out front, and then times the derivative, natural log of something, so 1 over the x squared plus x plus 1. Am I done? We're not done, because remember chain rule, you do the derivative of the outside, now times the derivative of the inside. What's the derivative of the inside?
2x plus
2x plus 1. Okay, and that was the derivative of the inside, so we're done there in terms of chain. In terms of cleaning this up a little bit, I mean, you can always leave it, but that's not necessarily ideal. This usually would be made as one fraction at least, where so the derivative of natural log of something is 1 over something times the derivative of something, that's that 2x plus 1. You would usually see that 2x plus 1 written on top. So I would say 2 ways to write this. You could say 2 times the quantity, 2x plus 1 over x squared plus x plus 1. Or you could go ahead and put that 2 on top of the fraction. You could distribute it out or not distribute it out. So this is going to be an or option. If I take that 2 on top and distribute it, we're going to be at 4x plus 2 over x squared plus x plus 1. Okay, so do remember, I would say one of those last 2. Okay, I think that was probably a rough example to jump in on because there's some confusion, I can tell. Yes, no, what do I need to answer
Can you
here?
just do like 2 times the 2x plus 1 and then multiply that against the other one? Even out.
Like that?
Kind of. You just put it on top of the other fraction.
You're saying 2 times 2x plus 1 times 1 over x squared plus x plus
Yeah. So it'd be like 4x plus 2 times the. That's basically what you did.
Yeah, that is-
Like up here?
Yeah.
Like put the 2 and the 2x plus 1 together and then leave it as this piece times the 1 over that piece? It's not wrong, but you're not going to see it like that often. And I'm trying to get you guys used to things you're going to see, if that makes sense. Is that?
Yeah.
It's not wrong. I would encourage you. Usually, you're almost always going to see them go that extra step there. Okay? Okay. H.
What we gotta do
Looks
is
like a nightmare.
the chain.
Well, there's a couple of different ways we can do this. However, and I never got you guys exponent or log rules, did I? Handed out. Well, just a page of log rules.
What is that?
Okay. There's a couple of different ways we can do this. Now, my first glance at this, and this is me, I don't always remember to think about log rules, is I see x squared times e to some power. And so x squared and e to some power, just thinking about that, I'm going to have to do the product rule. But then there's also going to be a chain rule within the product rule. Now, what I'm going to suggest, let's clean this up a little bit. E to the negative 4 ln x. Where can that negative 4 go? Well, in terms of, it's in the exponent. It's already in the front of the exponent. And that negative 4 is in front of the log. Where can I put that? In other words, what did we just do over here? We took the power and moved it out front, yes?
Yeah.
Can we reverse that? You can. The rule works both ways. So we can take this coefficient and put it out up in the power. So e to the natural log of x to the negative 4th. Now there's a reason I'm doing that. I don't know if you see it yet. What's the base of natural log? E.
Oh, it's what he's equals negative 4.
Not negative 4.
Negative 4x.
X to the negative 4. Remember when this and this are the same? It's equal to whatever is inside the natural log. So we already have the x squared, and this is just equal to x to the negative 4th. If you see this, this makes the problem 100% easier, which is where I'm trying to take you. Okay? But remember the log. If the base of the problem and the base of the log are the same, it's equal to whatever is in the exponent, which is x to the negative 4th. Now, what do you know about x squared times x to the negative 4th?
You can just add.
Yeah. Bases are the same. You're multiplying, so the shortcut is to add the exponents. 2 plus negative 4 is negative 2. We just went from a very difficult problem to a much easier problem. How do I do the derivative of x to the negative 2nd?
Take 2 up front.
Wait, it'd be negative 2 over
X.
x to
X to
1.
the negative. X to the 3rd.
So you guys are jumping straight to the answer, which, hey, you're saying this?
Power to the 3.
Yeah.
Okay. So I agree. Negative 2 out front, and then you subtract 1 from the power. It's x to the negative 3rd. Now, officially, our power was our outside rule, the chain rule. We didn't talk about the chain rule at the time, but the chain rule would be saying, what's the derivative of x? The derivative of x is 1. So really, you can always use the chain rule. We just don't need it when the inside derivative is 1. So don't leave the exponent negative, so negative 2 over x to the 3rd. Okay? Okay, ready for the next one? Yeah, you are. As ready as it's going to get. How's that?
Yeah.
Okay. So, What do you know about cosine squared 4x minus sine squared 4x? What's another way to think about those squareds? Okay. Realize we did one like this yesterday, yes? When it's cosine squared, sine squared, think of it, that's cosine, the whole thing raised to the second. Sine, the whole thing raised to the second. So cosine of 4x raised to the second. Sine of 4x raised to the second. Okay? So, with this in mind, let's work on derivative. Cosine 4x raised to the second power. What's my outside function here that we're going to take the derivative of? The squared. So how do we do something squared? I'm just working on one term right now. Don't worry about the sign yet. Is that what you're asking about?
Yeah.
We'll get there here in a moment. I've got to work with one term. So cosine to the second. How do I do that? 2 out front. Still cosine of 4x. And now it's going to be raised to the power of 1. Now, before you continue on, the outside was the power of 2. Is there an inside I can take the derivative of?
Cosine of 4x.
Yeah. What's the derivative of cosine of something? Negative sine of the same something, yes. That something doesn't change. So derivative of cosine of something is negative sine of something. Do I have another inside I need to take the derivative of?
No.
What's my inside of the cosine function? 4x. So what's the derivative of 4x? 4. And actually I should have said what's the derivative right here. Okay, so here's the idea. We did the outside power of 2. And then my inside that I didn't touch, that I kept the same, was cosine of 4x. Derivative of cosine of something is negative sine of something. The inside that I didn't touch was the 4x. Derivative of 4x is 4. 4 has no inside, so I'm done with that term. Now, that was only the first term. So minus. Derivative of sine to the 4x raised to the second power. What happens? 2 out front. So 2 times sine 4x raised to the first. So the derivative of something to the second we did. What's the something? What's my inside? Sine of 4x. What's the derivative of sine of something? Cosine of something. So cosine of 4x. What's the inside on cosine of 4x? 4x. What's the derivative of 4x? 4. And that doesn't, there's no inside there. Okay? Prop your foot up if you want. Okay. Okay, continuing along. This needs some serious cleanup. The derivative is done, but it needs some serious cleanup. Okay? Think about, there's basically two big long terms here, right? As we clean this up. Okay, so on the first term, I don't know about, what do you guys see? I see a 2 and a 4 and a negative that I'm going to multiply to put out front as my coefficient. Are we okay with that? Okay, because that's like a negative 1 there is what that is. So 2 times 4 times the negative is going to make that negative 8. And then what are my other pieces? Cosine 4x, sine 4x. Okay? Can I repeat the process down on this other part? I see a 2 and a 4 again. And technically it's a minus. So minus 2 times 4 is going to be minus 8. And what are we putting together here? Sine 4x, cosine 4x. Okay.
Do it again. Like, keep cleaning this up.
Can I keep cleaning this up?
Negative 16 sine 4x, cosine 4x.
Yeah. Are these like terms?
Yeah.
They are. It's like saying negative 8xy minus 8yx. Are xy and yx like terms? They are. They're harder to recognize it sometimes, but yeah, you do get to go another step here. Good catch. So negative 8 minus 8 is negative 16 cosine 4x sine 4x, which could also be written as negative 16 sine 4x cosine 4x. Okay. Okay. Jay? We're not as into this as we were yesterday, are we?
Possible.
What was in school?
Okay. Y equals x to the fourth sine squared x. Keep in mind that sine squared x is the same thing as saying,
2 sine.
not yet, x to the fourth times sine x quantity squared. And I don't know if you need to think of that squared outside like that. I mean, you don't officially have to write it like that, but I look at the fact we're beginners here. Okay? Now, what's the catch here?
We have to do the chain.
We have to do the chain rule, but we also have to do, we've got an x to the fourth and a sine x quantity squared. Are those both things we can take derivatives of? Yeah. These are two functions being multiplied together,
Product.
so we have to use the product rule.
What's the statement?
So we're going to use the chain rule within the product rule. Okay? Now, product rule. How does the product rule work?
Wait, am I thinking the wrong thing?
No, you're okay.
F prime times G plus G prime times F.
Inverse.
Okay. So, either way, they're using F's and G's and primes and stuff. It doesn't matter which order you go in, right? It's product rule. It's derivative of one, keep the other. Plus, reverse the scenario. Derivative of the other, keep the other. Okay? So, you guys okay if I start with the just derivative of x to the fourth?
Yeah.
What is derivative of x to the fourth? 4x cubed. And then I'm going to keep the sine x quantity squared. I'm actually going to write it as sine squared x right now, I think. That's the first piece. Derivative of the x to the fourth, keeping the sine squared x. It's product rule, so we are adding. This time, we're going to keep the x to the fourth. And we're going to do the derivative of sine x raised to the second. How do you do the derivative of something raised to the second? It's going to become 2.
Cosine.
Not yet.
What?
You have to keep the inside the same the first time through. So you're doing the derivative of the outside. The outside is something raised to the second. How do you do something raised to the second? You bring the 2 out front, subtract 1 from the power. So 2 something to the first. Then, once you do the outside, now we're going to do derivative of the inside. What's the derivative of the inside? Derivative of sine x is cosine x. And the derivative of the inside here, well, the derivative, it's just x is your inside, and the derivative of x is just 1. You don't have to worry about that. Okay? Be careful. The mistake keeps happening. Don't take the derivative of the inside till you finish the derivative of the outside. Let's see. there's not a whole lot of cleanup you can really do here. That first term, 4x cubed sine squared x is pretty solid the way it is. About the only thing I would clean up here is x to the fourth times 2 and write that as 2x to the fourth. And so it's 2x to the fourth sine x cosine x. I personally am fine with that. I do have an or in my notes. The or is just there's a GCF. What GCF could I factor out?
No, x to the power of 3. 2x to the power of 3. Sine x.
Nice. We combined it all. Power of T.
We got it.
Are you guys there?
Power of friendship.
No.
Both? Okay, so we're looking at two terms. 4 and 2. The GCF between 4 and 2 is 2. X to the third, x to the fourth. They both have at least an x to the third in common. Sine squared x, sine x, cosine x, they both have at least a sine x. Okay? So now, the first term. If we divide away 2, we have 2 left. If we divide x cubed, it's gone. Sine squared x divided by sine x leaves us with sine squared x. It was there. I'm dividing out GCF of sine x, so that leaves me with sine x. It's the idea of thinking x squared divided by x. It's that basic idea. Except ours was sine squared x divided by sine x. Okay. Plus, now, second term. 2 divided by 2 cancels. X to the fourth divided by x to the third. X. Sine x cosine x divided by sine x. Cosine x. I'm not saying you have to write it like that. No way. I'm not saying that. However, if they give this problem and say take the derivative and they put it multiple choice, could they put the answer like this? They can. Which is why I keep showing it and annoying you guys with it. Okay? Did I get everybody caught up? Okay. Moving on then. Okay. H of x equals natural log of x. It's an interesting one, isn't it? Okay, so realize, first of all, this is not natural log of x times natural log of x, is it? This is natural log of what's on the inside of natural log of x? Or what's on the inside of natural log? Natural log of x. So, the outside function is natural log. What's the derivative of natural log of something? 1 over something, right? We normally say what's the derivative of natural log of x, and you guys tell me 1 over x. So what's the derivative of natural log of something? 1 over something. What's in place of the x? Yeah, this whole thing is in place of x, so natural log of x times. So derivative of natural log of something is 1 over the something. Can we take the derivative of that something?
Yes.
Yeah. What's the derivative of natural log of x? 1 over x.
Can we just multiply these?
Mm-hmm. How would you write them if you multiply them?
1 over natural log of x.
Not exactly.
1 over the natural log of x.
it down.
Good job,
What
Augie.
did you win it for?
Oh, you got the
Do you not have Mr. Huntley in class?
No, I do, but
Oh.
like I stayed and helped there.
I just thought maybe he doesn't see you to give it to you, but it's the yellow tickets that the teachers have to turn in, so maybe, I don't know. Okay, now, I'm going to say no to natural log of x squared because this x is not part of the natural log. It has to stay outside.
X natural log of X.
So the best way to put this is x natural log of x, because then I don't have to question, is that x on the inside or outside? You could say natural log of x times x, but you have to be careful to realize what x is in and what's not in. Okay? We're in the heavy-duty derivatives here, aren't we?
Yeah.
Okay. Ask the questions as we have them. Okay, ready for L?
What? E to the pi x. God, what are we doing?
Okay, just start with the outside. What's outside?
Sine.
What's the derivative of sine?
Cosine.
Okay, so the derivative of sine of something is cosine of something. Don't change the something. Okay, I keep using that vague word something because it varies, right? So derivative of sine of anything is cosine of anything. Now, unless that anything or something, whatever you want to call it, is just x, which it's not, right? You now have to do the derivative of that. So now, my insides is e to pi x. What's the derivative of e to any power?
Oh, I got it.
E to any power.
E to that power.
Never mind. I got it.
Touchdown.
Now, is that power just an x?
No.
No, keep going.
Like,
You must keep.
Okay, wait.
What's the derivative of pi x?
Oh goodness.
It's
Pi.
no, pi.
yes, it's pi.
How is it pi?
Because it's the derivative. It's x to the
It'd be
1
like 2x.
times by 1.
Yeah, it's like me asking what's the derivative of 2x. And if I say what's the derivative of 2x, you're going to tell me 2. Pi is just the particular constant. So what's the derivative of pi x is pi. And that's just a number, so we're definitely done.
Yeah.
Okay?
How pi is.
In terms of writing this one doesn't have a whole lot of cleanup. That's what I figured I did. And it's not that you can't leave it as is, but I tend to put my constant out front. Pi is a constant. And then I'm going to write e to the pi x cosine e to the pi x. Just because I tend to put my trig functions in the end. Excuse me. Okay. M.
Holy crap. Okay. Now we can do this, guys.
We got it.
Derivative of the outside.
And what is the outside?
Or
2
cosine.
No, 2 squared.
Wait, you could write the squared on the other side of the pi.
Okay.
Yeah.
If you need to. Okay. Now keep in mind, the squared is on the cosine, right? So I'm going to say 4 cosine of pi theta quantity squared.
So the 8 cosine.
Okay, I'm there. G prime of theta, so the outside power is something squared. So multiply 2 out front becomes 8. Inside stays the same, so cosine of pi theta. And now this is raised to the power of 1. Not that you need to write the 1, but I've just been doing it for emphasis. So the outside was the squared.
Then we gotta do cosine.
What's the derivative of cosine of something?
Negative sine.
Negative sine of something, so that inside piece, which is pi theta, stays as is. And then, Unless that inside piece is just a plain old variable, you now have to do the derivative of the inside piece. Derivative of pi theta.
Pi.
Yay.
Okay.
Get this.
Do you see how you want to write it up? Write it up, clean it up.
Pi.
A pi.
Negative 8 pi.
Yeah.
What?
no.
Oh.
I would do negative 8 pi because you're putting all your coefficients out together then. Do we see all of that? Negative 8 pi negative 8 pi cosine pi theta sine pi theta. It's a mouthful. We're getting there. We're getting there.
Oh wow.
Oh, tangent.
It's a lot.
Okay. In. Like this is a one with like 28 parts or whatever, but do you feel like any two problems have been the same? I mean, they're all different. That's the thing. So, okay. What's the rewrite on this one before I get started?
Tangent of 2x minus
Okay, now the question is, do you guys see how this one is set up?
What do you think,
Probably
bro?
not.
I hope you are realizing this one is slightly different than a lot of the other trig functions we've done today.
It's got tangent.
It has tangent, but is this whole tangent thing raised to the 1/2 power?
No, just
No.
2x minus 3.
Just the 2x minus 3 is raised to the 1/2 power. So the outside function is tangent.
Yes.
What is the derivative of tangent of this mess?
Secant squared.
What?
Derivative of tangent is secant squared. That's one of our memorizations. Okay? So derivative of tangent of something is secant squared of
Something.
something. You could go ahead and put it in the square root form right here if you wanted to. I mean, times. Now, what's the next outside piece to be done? You have something raised to the 1/2, because this is my inside piece of tangent, but something raised to 1/2. How do you do the derivative of something raised to 1/2?
Move it up front.
So it's going to be 1/2,
Gonna be to the negative.
still 2x minus 3, subtract 1, and so it's a negative 1/2. Am I done?
No, you must move it inside.
And then, whatever we did was raised to the power of 1/2, the inside of that is 2x minus 3. Derivative of 2x minus 3?
2.
2. Okay. Actually, there's some really good cleanup on this one.
I say it's just
Multiply the 2 and then
Oh, I see
something.
I see something.
secant
square.
2 secant, and it's like the 2x minus 3 goes on top, and below it goes square root of 2x minus 3.
Okay. So 1/2 and 2 canceled, right? 1/2 times 2 cancel. This secant squared of the square root of 2x minus 3 stays on top. This is a negative 1/2, so it becomes a square root in the denominator.
Can you cancel those?
And why can I not cancel them?
Because connect to the secant squared.
The one on top is the insides of the secant squared. If you cancel that one on top, you no longer have, you need a variable inside your trig function. And that's my variable inside the trig function. Okay? It cleaned up. Maybe not what you were hoping for, but it cleaned up.
Holy.
Okay.
That's big.
That's good because we're like at 15 minutes left of class. A through N took us a time. No, we didn't even do A through N, did we?
G.
That was G through N. Oh. Okay. Example 4. Let f be a continuous and differentiable function on the interval from 0 to 1. And let g of x equals f of 4x. The table below gives values of f prime of x, which is the derivative of f of x. Find the value of g prime of 2/10. Okay. Start with this. I don't want to plug in 2/10 yet. So hold off to the 2/10 and let's worry about g of x is equal to f of 4x, correct? We're being asked to find g prime of something. So use this rule to find what the rule for g prime is, and then we'll go from there. Okay, so g prime of x is taking the derivative. On this right-hand side, what are we thinking there? If we take the derivative of that right side, it's going to be what? F prime of, not 4, 4x. You're combining your two steps. F prime of 4x is the derivative of the outside. Leave the inside as it is, so thus I left my 4x as it is. But then, what do we have to do? Times the derivative of 4x, and the derivative of 4x is 4. Okay? So there's your derivative of g prime of x. What were we asked to do? G prime of 2/10. So what do I need to do? Fill in my x's as 2/10. So now I'm doing g prime of 2/10 is equal to f prime of 4 times 2/10 times 4. What is 4 times 2/10?
8/10.
8/10. So I'm going to put this 4 out front. I'm doing 4 times f prime of 8/10. Do we know f prime of 8/10? We do. So g prime of 2/10 is going to be 4 times 1.125. Yes? .5 if I did my math correctly?
Yes.
I did what you guys have to do, right? That's very doable. 3 numbers after the decimal, so I moved my decimals over 3 places. I hope you're that much more thankful for your calculators now. Okay. Good application of tables, right? You see tables, you're seeing them a lot this year. They gave us everything we need to know in the table, you just had to get to that point. The key there is to not forget about the 4. Now, and I will say, like, Caitlin, you just wanted to say f prime of 4. I would have been stuck there, wouldn't I? Because I don't have a 4 on my chart. So that would have been the clue that this has got to come up to be something on the chart. So, okay. Number 5, use the table to complete. This is find the equation of the tangent line to x equals -1 if h of x is 3f of g of x. Okay. h of x is defined to be 3f of g of x. Well, shall I go ahead and jump right in that we're going to have to find the derivative? Yes. Why do I need the derivative? Because? What's the derivative going to find for me here? Equation of the tangent line?
What? Oh, it'll find us the slope.
The slope, yes. Your derivative is the slope of the tangent line. So that's why we need to find the derivative. Now, again, before you plug in the -1, start with h prime of x. Okay. 3f of x of g of x, or f of g of x. What's the derivative here? What's the outside? 3f essentially?
So 3.
No. Think, I guess, more of your outside being 3f of x. That 3 just carries along.
So 3f prime.
So 3f prime. So 3f prime of your inside stays the same. So it stays g of x. And then times the derivative of g of x, which is listed as g prime of x. Okay, what do we need to do with this derivative? Plug in -1, yes? Right, Caitlin? -1? Okay. So plug in -1, so 3 times f prime of g of -1 times g prime of -1. 3. Now, f prime of g of -1. What do you have to do first here? Get g of -1. So don't worry about f prime yet. It carries along. What is g of -1? -1. So that's going to replace in terms inside g of -1 is replaced with -1. It's still inside f prime. Times, what's g prime of -1? 2. One more replacement. So I have 3. What's f prime of -1?
4.
Times 4 times 2. 3 times 4 times 2 is 24. What is 24?
That is the slope. No, yeah.
We have a slope of 24. Okay? Because h prime of -1 equaled 24. Am I done?
No.
Tate is on his tests. It's like Caitlin. Caitlin used positive on her test. Tate stopped here. Don't make these mistakes. I'm not done because it didn't just ask me for the slope. It asked me for the equation of the tangent line. What else do we need besides slope? You need a slope and a point. Well, we know my point is going to be -1 something.
We'll plug that into the original equation.
Plug it into the original equation. So, in order to do h of -1, it's going to be 3 of f of g of -1. Right? So, 3 times f of, what is g of -1? Did we already use that? We did, didn't we? So that is -1. And then you're doing 3 times f of -1. What's f of -1? -2. 3 times negative 2 is negative 6. And so what's that tell me? My point is negative 1, negative 6. Can you write your equation now? Okay, sorry.
It's negative.
Yeah, it is. My mental math messed up on that one.
It's alright.
Okay. Hopefully you guys did better than I did on that one. Okay, you got it? Okay. If j of x equals f of g of x times cosine x, what is the value of j prime of 0? So we've got to find j prime of x. What do we have to realize here?
Can the f of g of x be like the something of the cosine? Or is that just totally wrong?
No. We've got to see this as I have f of g of x
Oh.
times cosine x. So we've got to see this as a product rule.
What crap.
Okay?
Yeah.
So,
There's no
derivative, we'll plug in 0 eventually. Derivative of f of g of x.
Is
F prime of g of x. That's the derivative of the outside
No!
times, what's it? So f is the outside,
G prime.
so times g prime of x. So that right there, that whole thing, f prime of g of x times g prime of x is the derivative of the first
Times cosine.
times cosine x.
Over 2.
That's product rule. So we're going to add. Now we get to keep f of g of x the way it is
negative sign.
times the cosine, which is negative sine x. Okay. I would just plug in 0 at this point. There's not really much cleanup that can be done. So, j prime of 0, we're going to be doing f prime of g of 0 times g prime of 0 times cosine of 0 plus f of g of 0 times negative sine of 0. Okay. Now, f prime on this first one just holds, right? What is g of 0? 2? Times. What's g prime of 0?
G prime of 0 is
Negative 3. Times. What's cosine of 0?
1.
1. Plus, other side. F is going to hold the way I do it at least. What was g of 0? 2. Negative sine of 0. Sine of 0 is 0. Okay, officially, we've got to do one last bit. F prime of 2. So negative 2 times negative 3 times 1. On this last bit, officially it's f of 2, which is 3 times 0, which is why I say officially. Do you even have to do that part? No. Does your math match my math? I have positive 6.
What? Negative times a negative is positive.
That's what I was going with. Okay. We got done. A minute or two to spare.
Work time.
Why is it so long?
35.
Ooh,
Oh wait, actually, it's
it is kind of long.
no, it is long.
No.
Yeah. It's 3 front backs.
Wow.
Wait, 3 front.
No, 2 front backs.